What's up guys, Chris here. Today we're going to talk about this pile of parts on the bench which will become a magnetic parts deburrer. But first, I'd like to talk real quick about the videos I've not been putting out lately. For those who don't know, I quit my job not too long ago to start doing this full time. And it's been going well, but it's been taking pretty much all of my time doing that. So I've got a Patreon page going if people want to help create these kind of videos. But I had a neat idea of what maybe we could do with that. The idea would be crowdsource projects that we want to build, and then as I have the time anyway, I can build or create those projects and build them and share them on YouTube and share them on Patreon. And the idea behind it being that while everybody can watch the videos obviously on YouTube, really appreciate the support there, the people who want to support Patreon and actually help me really create these things, they can get access to the the drawings for it, the code, bill of materials, any of that kind of stuff that you would need to create your own version of these projects. This one, magnetic parts deburrer, I've had ideas for doing a small injection molding machine, some sort of version of an automatic bandsaw, and or an automatic cold cut chop saw. I guess the majority of the projects, obviously, being things that I want for myself, but also stuff that is good for the hobbyist community to have, people who are working out of their garages and can't necessarily spend thousands of dollars on a piece of equipment that is nice to have but may not be something that you need all the time or you can justify spending the money on. This actually, if it wasn't sort of a hobby, I am trying to use it for the business. I've started making these titanium keys, computer keys, and right now I'm using this thing behind me, which I hooked up to my old mini lathe. It's basically just a wooden box with this foam rubbery material inside to keep it waterproof and to kind of cushion the media inside. But it's like a rock polisher. It takes a day or more to do any parts in it. So this would be quite a bit faster, at least hopefully. But yeah, just small things like that. I don't know. Let me know what you think in the comments below. It's just a thought that I had the other day, since I don't have time to produce, a weekly video or bi-weekly videos, whatever. That might be an interesting way to kind of keep the channel going and to also make some really cool, useful stuff that people out there can replicate if they have a need for something like that too. So let me know what you think in the comments below. Anyway, getting back to this project, the magnetic parts deburrer. The idea is you have a motor which spins a platter with strong magnets on top. On top of that, you put a container, a bucket, something like that, non-magnetic obviously, and you put magnetic stainless steel media inside of there. And you spin the magnets underneath it, and that kind of agitates the whole mixture as well as your parts. And really, it acts like a vibratory tumbler or something like that. I don't know how well it'll work for magnetic parts. Those it might not work too well on anything steel. But I don't do a lot of steel. I do mostly titanium and aluminum, copper, brass, bronze, those kind of things. So for me, it could be a very useful tool to have. The original thought was to just use like most of the other people who built these machines, the original idea was just to use a standard three-phase motor and a speed controller, a VFD or something like that. But then I got to thinking, I wanted to make something really cool, something that was could compete with an actual product. And I thought it'd be really nice to have a micro-controlled motor, something that you could set up parameters for, save them, recall them later, set up specific parameters for certain jobs that you do. And that's when I thought about these Clearpath servo motors. These are the same motors that I use in the DIY VMC machine that's out in the garage. They are made by Teknic, made actually here in the US. I think it's, forget where, East Coast somewhere. But one of the things they make are drop-in stepper motor replacements, where they take power from a power supply, and they, being a servo motor, have all the controls and everything built into the motor. So all you do is supply power and step and direction signals, and it will act just like a stepper motor, but with an encoder inside that keeps track of the position. So that's really cool, and they're not too expensive. They are more expensive than a stepper motor, but they're also more powerful. But they're a lot less expensive than a standard servo encoder controller looped system. So I'll put links below to all this kind of stuff. But I got in touch with them, and they hooked me up with a motor and a power supply for this project, so big thanks to them. And that opens up a lot of possibilities for microcontroller control. So it's a very interesting option. It's very cool stuff, and I hope to use them on quite a few projects, because they're a nice all-in-one compact solution that can do a whole lot of cool stuff and give you feedback, like actual torque output of the motor, actual RPM, positioning error if there is any, just all kinds of cool stuff. But we'll look at that in a little bit. So with all that out of the way, let's move you over to the bench here, and I'll show you what I've got so far. Alright, so here's what I have so far. We've got our Clearpath motor, servo motor, and its power supply. Then we have an Arduino, a little touchscreen, and a couple buttons, and a rotary encoder. These I got from Adafruit, but you know, you can use obviously any buttons you want and whatever screen you want to get to work with the Arduino. But I will get a parts list going. If anybody wants to build this thing, you can just download the code for the Arduino, buy all the same stuff, wire it all up the same, and you'll be good to go. So quick run through of what I've come up with as far as the software side of things go. This is a little touchscreen, as well as you've got the actual control for the motors and stuff is physical buttons. There are 4 different modes. Manual mode. You'll excuse my fingers, I have normally dry skin, and it's cold and dry here, so it's even worse. Touchscreen doesn't work as well for me as it will for most people. So when you're in manual mode, this is if you just want to try something out or whatever, you can set your RPM to whatever you'd like it to be, up to about 3000 RPM, and the Arduino, it's using pulse width modulation to control the motor. So the motor will see any duty cycle between 0 would be off and 100% would be full speed. The Arduino can only output 256 discrete steps of pulse width modulation. So this thing will see, instead of, you know, essentially infinite numbers between 0 and 256, it'll have 256 steps. So as you watch the RPM, one click up, 2232 will then go to 2244, 2255. So it doesn't have infinite control, but it should be more than enough for this kind of application. So you set the RPM you want, and then you can hit the green start button. Careful. Get that out of the way here. And it'll just run. And then you can adjust the speed. This just changes the pulse width signal going to the motor. Go as slow as you want. And then when you're done, you can just hit stop. And then you can go back. There's a timer mode if you want it to run for, let's see, you want it to go 750-ish RPM. Click the button, you can set how many hours you want to run. Click again, you can set how many minutes you want to run. It's a little touchy. That can be changed in software. It's kind of a balance between, You can make it less touchy, but then it takes longer to scroll through. Up to, say you want to do 45 minutes, you'll be there spinning the thing for a long time. So that's configurable. I have it kind of somewhere in the middle right now. 1 minute to run at 767 RPM, hit start. The timer will start counting down and it'll run. And then once it gets done, it will automatically turn itself off and go back to the home screen. Of course, you can stop it early if you need to. And then the cool part, and the part that took the longest, because I didn't know when I started out, this is kind of my first Arduino project, and I think if you look way back in the channel, I tried to make a VU meter using one. I don't know if that's actually have a video of that. I have the video using proper chips dedicated for that, but that was the first project I actually used an Arduino for, and that was this one. It's been sitting in the closet since then. So this is really kind of my first Arduino project pretty much ever. So this has taken a fair bit of time, lots of nights trying to get this going, but I didn't realize that this had no easy way to store variables or values once it lost power. It doesn't have like a flash memory card, you know, that you can just write to. There's the EEPROM, which is 1K of memory that you can access, but it's a little bit of a pain to use it. But anyway, so there's automatic mode, which you can use after you've set up a profile. So you can go into your profile manager and say profile 1, I have it set up for titanium keys, just as an example, 803 RPM for 5 hours and 20 minutes. Profile 2, general deburring, 1000 RPM for 15 minutes. Say we want to run that one. Well, I should go through. You can edit it, and you can change the name, which if you want to give it a new name, you can scroll the wheel here and go through all of the characters and numbers and a few symbols, and then just click to go between, double click if you want to go back. And then you can save it, and then the same thing for, that should go to a different screen. I'll have to change that. It should go back to probably this screen. If you want to change the specs of it, RPM, hours and minutes, you can go through and you can change that as well. But anyway, you can set up to 10 profiles for any repeat kind of jobs that you do a lot. And then you can go into automatic mode, and you can pick, say I want to just do general deburring. You're good. You just hit start, and it will do the same thing. It'll run at the RPM for however long you specified it to, and then it will stop, which we won't wait 15 minutes for that. And that's kind of it. It's really simple. It's nearly 2,000 lines of code. I'm not a particularly great programmer yet, and I will put this out on GitHub if you want to improve. Basically, I'm going to get this kind of finished up, and then I'm going to be sort of hands off. I'll let the community do whatever they want to do with it. You can probably optimize this better, better graphics, all kinds of stuff, but that's a whole GitHub thing. Do what you want with it. I am probably going to leave Arduino now in the C programming and move into CircuitPython, which is, from what I understand, supposed to be the latest and greatest thing. And if I'm going to start learning something, there's no sense in learning kind of, well, I shouldn't say that. C and C++ and those things, they have their uses. A lot more critical applications you might want to run and see if you got really tight timing or something like that. It's a little bit faster, but for the kind of stuff that I'll do, there's no need for me to get into that. And Python is supposed to be a whole lot easier to use. And Adafruit has some really cool modules that can run on that. I can actually run Arduino code too, but my point is I'm not too interested in optimizing this myself anymore. So I'm going to be, like I said, I'll leave this one. This is the Arduino that I happen to have, which is why I chose to go that route to even begin with. And I've got some new boards coming that run the CircuitPython language. So I'm gonna probably start on that next and kind of not look back into Arduino. So have fun with the code, do whatever you want with it, customize it however you'd like. But projects from here on will probably be written in Python, which I kind of know nothing about yet, but so long as I'm going to learn something new, might as well learn what's modern and supposedly the latest and greatest. So yeah, that's pretty much it as far as the electronics go. Just some buttons, resistors. It's all wired up. The encoder just runs, or is just wired up according to the data sheet. Couple resistors, couple capacitors. Switches are just standard switches, momentary switches. Yeah, that's kind of it. Really not a whole lot going on here, but should be more than enough for what this project is. So let's go to the computer real quick. I won't go through all the code and stuff. Like I said, it'll be on GitHub if you really are interested, but there's no sense in running through all that code. But I will go into the Clearpath software, and we can see how I got that set up to interface with the Arduino or any other microcontroller if you're going to output a pulse width modulation signal. So let's go take a look. Alright, so here we've got the Clearpath software. You plug your motor in just via USB cable and the software will find it. This is where you would set up basically everything about your motor. One of the first things you would do if you actually had it in the device that it's running in, under the setup menu, you would go to tuning and auto tune. And this will actually, it will move the motor around, and it will actually use the sensors to determine how the motor is performing in that particular environment, and it will adjust things automatically. I have not done that yet because I don't even have the machine built, so it's still using the default tuning values, which is fine. But you can set up your different modes here, which again there'll be links to the videos down in the description. Cool stuff. I mean, even if you don't plan on buying any motors, just what you can do with these is really neat. I love the follow digital torque command video. I don't know where I would ever use it, but it's kind of neat to see. Anyway, you could set things like your maximum RPM, your acceleration, whatever you might need. Most all of your settings can be set in here. You can see things like the actual power that the motor is drawing, as well as a max value. You know, if you've got it hooked up to something and you want to see what the maximum power it takes at any given instant, you can see that. But one of the coolest things, especially for troubleshooting, is this scope. So right now I've got my little Arduino thing hooked up, and if I turn the knob on the manual screen, we can see down here the one of the inputs is the actual pulse width frequency, or I guess the duty cycle coming from the motor or from the Arduino, and you can actually see it up here too. It's 2% right now, and as I turn it up, you can see the physical pulses as they come in, just like a regular oscilloscope. And you can also see, you know, it's 45% is what's coming in, and that tells it to run at 1359 RPM, which on my little screen is 1358. So that's pretty close. And then you can set, just like a regular oscilloscope, you can set different inputs here. So for instance, if I wanted to see when I turned it on, let's just do the velocity. Yes, the measured velocity of it. So when I hit start, you'll see it ramps up, and it's running at, well, the scale is 500 RPM per division, so 1,000, just short of, it's about 1,300, which is just easier to look up and see. The velocity is 1359. You can set up a second channel if you want. You can see the torque at the same time. So the torque is practically nothing right now, which makes sense. There's no load on the motor. And then when you stop, you can see that fall, and you can see the torque there. Let's see, if you set it to normal mode. I'm not great with oscilloscopes, so yeah, bear that in mind. So let's hit start. There. And we can actually see the real torque as the motor is ramping up, which is really cool and very useful for things like the CNC machine that I built. I was able to use this to fine-tune the acceleration values and stuff to make sure that what I was telling the motor to do was something it was happy doing. So you can hit stop. And let's see. There's just a bunch of cool stuff in here. You can see the actual voltage that you're getting from the power supply. Let's see, auto. There we go. 25 volts per division, so that's 25, 50, 75 volts, right on where it should be. Oh, the jerk. Yeah, you can set that. If you're familiar with the CNC controller settings, you'll know there's a jerk setting in there. You can actually hit that. This has a facility to do that as well. I don't know that it does in this mode because it's not running like a stepper motor would be in a CNC machine. It's just going to a specific speed. If I hit start, yeah, it really doesn't do anything as far as jerk goes in this mode. Yeah, you can see there's all kinds of cool stuff in here. You can, for instance, you could watch the torque that it tells it to go versus the torque that's actually measured. So if I hit start here, back to normal mode. Stop that. Start again. There. So you can see that, oh, I shouldn't have done that. I will just leave it here. So you can see the blue line is the torque that it told the motor, or should have run at, I guess, and the red would be what it actually ran at, which is really very cool. So yeah, it's just it's very neat software. These are the only motors like this that I've ever seen. But yeah, that's the software. Like I said, I'll have links below to their videos, which are a lot more comprehensive and better informed than mine. But I still wanted to be able to show you. Yeah, you can see your enable inputs down here when they were enabled, and then when it cut off, when I hit the button, it turns off. So a lot of diagnostic stuff that's just really handy to have. Very cool stuff. So yeah, I guess that's it. Let me know in the comments what you think about the whole idea. Also, I need a name for this thing. If you got some sort of clever name, leave it down in the comments. I want to call it something other than the magnetic parts deburrer. Also check out Teknic's website, links down below. Really cool motors. Really appreciate them helping out this project. Patreon as well, if you want to check that out. There's not a whole lot going on over there just yet, but you know, it'll take some time. Other than that, part 2 will be coming soon. The mechanical design. Still got to get all that buttoned up. I've got most of that done. It's not quite ready to show off yet, but it's about 90% there. Now that I've gotten the electronics done, I can finalize how that's going to fit in, and then get the whole thing wrapped up, and that will be part 2. So stay tuned. Take it easy. Steel media and some. Oh! Well, I'm gonna have to get another one of those. It smells. It's a good thing we aren't on the. It smells like there were sparks when they slammed together. I mean, these are strong magnets, but I didn't. They were on two opposite sides of a door when I pulled them off. But what does that smell? It smells like, can't quite place it. Actually, probably toxic.